Hi, my name's James Clarkson, and the topic of today's chat is looking at how to avoid using Control C, Control V to create reports. There can be a huge amount of time, especially when we're looking at damage stability, involved in getting uh, all of the permutations of intacts and our load cases and our damage cases, all those permutations, all the data points we want across into a report. All of that manual work is fraught with danger of little human errors in there, and it all takes a really long time. If we then need to go back and iterate and update our design, uh, then we're putting in more and more risks of human error each time we go and do something like that. So in MAXSURF, we can use the COM interface, the Common Object Model interface, to talk to the software from different packages. And so in this case, we're going to use Excel and VBA to talk across to MAXSURF. So what I've got here is an Excel sheet, and there's some VBA running behind it. So we're going to start by talking about what the sheet does, and then we'll talk about some of the bits of the VBA behind it. Now, this is not designed to be the solution to your problems. This is an example that's for you to go and edit, tweak, change, and modify. VBA is really well supported on the web, so you can find information about how to do all of your syntax and what you can and can't do. And so it's a really good way to pick up some basic programming and learn those skills. So in this script, you'll see that we've got 3 buttons. Clicking on these buttons runs some scripts in the background. The first button generates a list of all our cases. Now, when we go and do an analysis, we don't necessarily want to analyze everything in our model. Light ship load case, for example, it's not a seagoing condition. We don't need to look at the damage cases of it. So we can omit running those results. Other cases, perhaps we're doing iterations and we don't need to go and look at, we only need to look at the one intact case that we've changed. Sorry, the one load case we've changed, so that we can look at how the damage cases have also changed. So we've kept the human in the loop here by creating a list to start with, and then we run that list, which lets us get in and intervene and modify where we need. Now there's also a column in here where if there's a mark in the column of any sort, then we're going to heal that vessel in what we think is going to be the worst heel direction for large angle, which will be the direction that its equilibrium position heals in. Now, that's not always going to be the right way, so we've also got this override where we can specify it's going to port or it's going to starboard. So as long as the first letter is an S or a P, then we'll go in that direction. So once we've got those cases set out, we can go and run step 2, which is to run all of those load case, damage case combinations. So that's working through cases to test list, and it brings the data out to these 3 sheets. So here you'll see my load case, damage case, and just a handful of the data. Now, you're going to want different data, and as I said before, this is all editable. It's designed so that you can tweak this to your needs. This is the data that we've gathered here for our equilibrium. We're also running a large angle stability, and so you can see here I've just grabbed some key angles through that main part of the GZ curve. Now you can be running from much lower angles to higher angles, etc. It's up to you what angles you run and what and what data you extract at the end. We're also keeping a record of are we healing to port us to starboard. Then the final one is our criteria data, and so you'll see that I've grouped them with pass, fail, actual and required. We do need to manually get the names of these criteria across. We can't access that programmatically, but that doesn't change all that often, so it's not too much of a hassle to do that. So once we've run the second step, we go and run all of those calculations. And so that's done all that and extracted all the data into Excel. And we could go and copy paste that straight into a report now. But we do need to go and do data checking on that and make sure that the results we've got are as we'd expect. So we also have an overview sheet. We do need to update the formulas just to match the sizes, so that the number of data points in our result set. And once we've got that, we can basically choose which data sets to pull together. And you can see here that I'm pulling in the equilibrium, large angle stability, and criteria results, so we can see it all in one place together. And so if we do have something that's failing, we can have a look and we can see if we can identify in that simple part of GZ curve what might be the issue. Now, there's a bigger problem. We can go back to the software and rerun that particular case in the software, but we don't need to go and rerun everything. And we can just go and have a look at that one case and identify if there's an issue there, and perhaps we've got to make some changes to our model, or we've got some other error, such as in our criteria setup. So that's how the code is working as it is. So let's now take a quick look at what's involved in the code behind the scenes. Now, the first one I'll point out is fairly standard across all MAXSURF, all COM programs, is that we need to tell Excel where it's getting MAXSURF. So this dim stab app becomes the name that we talk about the stability application with. And so then we'll see that further down whenever we want to talk about talk to stability, we've got to use that stab app to refer to it. Now, there are two modules that we're using here. Criteria Simple just has that accessing the criteria, and it's basically going through all of the criteria we have and seeing which ones are active for damage and looking at the results for them. Most of the grunt work is in module 1, and you'll see that it's step 1, step 2, and each of these goes and calls up different routines as well. So you'll see here we call up set ranges, which is this one where we define names for our worksheets and names for particular cells within those worksheets, so that we can go and just in one place we can define where everything is being written to. That means if we want to make a change to the layout of our sheet, gives a little bit more room at the top for headers or something, we can just change it in one place here, and that will be consistently pushed through the document. Now, when we scroll down, maybe I'll grab from here, calc and extract data. So this is where the grunt of the run the calculation and pull out the data points that we want is coming from. So here we can see that we set the mode to be an equilibrium analysis, run that analysis, and then we give a name to our equilibrium results and our margin line results as well. So down here, we're using that equi result name, and we're looking at the results for our equilibrium. Now, if you want to get different results in here, then actually, sorry, I've already put it in. Then yeah, it's just a case of adding more lines in, and you can go and get whatever data points you want. Just make sure that we're putting it into a new column each time. When we scroll down further, we'll see that we change across to our large angle stability, set whether we're heeling to port or to starboard, and then we run that analysis in there somewhere. I'm not sure where it actually runs. Oh, it runs the analysis. And then we go and extract our results. So I've actually gone and run this at every 5 degrees, but these are the only results that we're extracting. I don't want to put too many data columns into my report, so I'm only getting these key points that will allow somebody that's looking through the report to understand what numbers are coming out and what's happening with that GZ curve. They don't need to see the details of every 5 degrees. If you did want something other than GZ, we could go and repeat this, offset it perhaps by a larger amount, or go and create um, a whole new range where we write out to, and we can go and get different data points from that GZ curve. So you could be getting your KN data or something else out of here if that was of more use to you. So that's a quick overview of how this code is working, what the code does. I'm going to leave it to you to go and play with it, tweak it, change it. You're welcome to make any changes and edit as you see fit. And hopefully it shows you a way that you can go and streamline that results processing, the time-consuming parts, so that you can focus more onto the engineering parts. Thank you very much for your time, and good luck with this.